Today is Wednesday, August 19th. I'm joined, not in the studio today, but at the bar. Today, I have Keegan in the studio with me.
Hello, thanks for having me.
Great to have you here. Today, we're going to talk about Keegan just went to RenderATL, probably one of the best JavaScript conferences in all of America, one of the most notable ones in the whole world. While you were at RenderATL, you created your own journey of being there, and then you got advice from a film director, a friend of mine, Jason Torres, and it's something that you've been really trying to use in your job hunt. We're going to talk about that. Then we are also going to use Keegan's app. Keegan made dumbflstudio. So this is a web application, and it is extremely ambitious. This web workload is able to go toe to toe with real native software that runs directly on an operating system. And this was built using the Vercel AI SDK. It's currently hosted on Cloudflare. And we're going to go through that application. We're going to talk about how it was architected, but then we're going to put it to the test because both of us are real developers. We know how to use the developer tools. We also know how to inspect the network tab. And what we're going to do is we're going to aim to find and report bugs, but we have one caveat. Keegan, what's the caveat we have?
I do not have my laptop with me, which means
What are we going to do if you don't have a laptop?
I don't know. I do know, actually. I have my phone.
You have your wait. Wait.
I
wait.
have
Are you going to have a runtime on your phone?
absolutely not.
Can you run Node on your phone?
Probably. But I can use Codex. If you don't know, Codex has a remote feature where I can use my desktop and just control it from my phone.
Aha. And so today, this ties into a very, very special stream. This is the secret for today's stream. The secret is, what is the difference between a professional developer like us and the amateur developer? And the secret is in the language itself. Amateur means to do something for the love of doing it. Being a professional means I'm doing this so I can provide for my family. I'm trying to do this at a predictable schedule, and I'm doing this for my lifetime. As an amateur, once you fall out of love with something, you go to the next thing. I'm a professional. I don't give a shit what Codex is going to do. I'm still going to be a professional builder. I'm a professional technologist. So is Keegan. So today, we're going to show you how we don't even need to look at the code. We don't need to be in front of our computers. We can look through the app and we can still ship more than you, even with a drink in my hand. Cheers.
Cheers.
Let's do this.
So you did point out one thing that I wanted to expand on with being a professional. One thing that I notice a lot that separates an amateur from a professional is the way they approach problems. For us, it's really serious that we get it right. And one tool I use personally to make sure that I get things right is by thinking about them before I attempt it. And not just thinking about it, but planning it out. This whole stream, we have what we want to talk about right here in front of us. If we didn't do this, who knows what we would be talking about right now.
Yeah, we got Keegan's keys to success.
Keegan's keys to success.
I like this. Double the C's, doubles the S, and you have success. So number one is plan and back test. But that's such a no shit Sherlock type of thing. I mean, look. But what I want to do is I want to pull you deeper, because to plan this, you can't do a normal fucking, oh, hey, Claude, plan this, make no mistakes.
Yeah.
It's not that. As a front-end developer, you're thinking with a front-end mindset. And I would think a front-end mindset has a lot to think about components.
Yeah. I mean, even in back-end work, you got to modularize things and break them apart, break the problem down. Everything is composed of multiple problems. There's not really one big problem that you can solve. it's solved by fixing and answering the question of multiple smaller problems.
So first we plan things, but then the thing is that if you have a plan that's too big, right? What would happen? Imagine I have a burger that's this size. How the hell am I going to eat it?
I can think of a few ways, and only one of them involves not vomiting.
So, but the trick is going to be no matter what the way is, we're still going to do it one bite at a time.
One bite at a time.
And so when we think with the component, this is where recursion still matters, because a lot of people say, oh, hey, I planned the top level. Now it's time to be done with planning. Oh, don't get into analysis paralysis, they'll say. But then you realize you have serious components. Look, let's take a look at some of the serious components that are inside of this. So let's take a look first and foremost. Look, inside of my web UI, I have multiple objects that can be dragged. And when I click on them, this is going to change the Z index and the layering. So that's one layer to think about. In addition to that, with the keyboard, I can play music. So that is another thing. I now not only do I have keyboard navigation, I have keyboard-based actions. Then in addition to that, I am not only using JavaScript. I am using what is inside of your browser, enabled through your operating system to work this. And every operating system has a different way of processing data, specifically multimodal data. And so we need to think about components. And the most important component that you thought about during this process were the web workers, right?
Yeah, so there's a subset of web workers that I'm using in particular. If you know anything about web workers, you know about messaging.
Mm-hmm.
You might have this big JSON payload that you need to message and process and then send back. That can be, really slow when compared to just, passing a reference to an object. So we use something called a worklet, and more specifically, an audio worklet, which I forgot what the documentation said, but it's a...
Let's just go to MDN.
Yeah, let's do it.
Back in the day, you would never just be like, you would never go to fucking Claude or ChatGPT. You knew you just came to one place, and that by coming to one place, you would know. Sorry, sometimes I get too passionate about this. I miss the web.
I love Indian. I mean, still, this is what I need to use to really understand something. So, audio worklet. So, yeah, the audio worklet is an interface to use the web audio API, like it says here. And as you can see,
we have custom audio processing scripts. And so what I think is going to be helpful is let's open up our developer tools. Let's go to our sources and let's reason about, well, where would I expect to see my web workers as a script inside of here? Do you think I would see it inside of the main workload? I'm thinking probably not.
No, I don't think so.
I think I might see this where I see some extra scripts, or this is where sometimes things get very challenging with web workloads. This is one of the main reasons why predominantly things run on the Chromium runtime, is because you have significantly stronger developer tools. And I will open this up in a Chromium-based tool. So keep in mind, you see so many browsers coming up. You guys are going to get recursion death real quick. Sorry about that. But I now have just reproduced the workload right here. I have the tabs open here. And now if I was to take a look.
So this is actually one thing that I wish was much easier to see and get a visualization on, is all the web workers or worklets you're using in a browser. Because I'm very visual and I like to kind of have an idea on what processing is being done on separate threads.
Exactly.
And I do want to point out, this is why I added an audio graph inside the tool itself. So if you click right there.
Click here?
Right here, the
audio graph.
So you'll see each one of these is a representation of an audio worklet. So we have our drums audio worklet, our bass, which is just one of the synthesizers, our chords, another synthesizer, lead, another synthesizer. So all the audio processing is being done on one audio worklet per each synthesizer.
Wow.
And you can see they're getting routed to this master bus here. This is another audio worklet.
So hold on, you said a bus. So this
a
is
bus.
an event bus.
Not necessarily. So when I say bus, it's more of an audio term where
Oh, okay.
they're being routed to like one process that has an input and then it outputs to the audio output.
Oh, that's interesting. Is that in the docs? Hold on, that. So I mean, this is like where the nuance is of like when you're working on development stuff, you have to find out where the nooks and crannies. Like you're gonna see a demo and you're gonna be like, "Oh my god, it's so cool," but then as the developer, you have to be a professional and be like, "How do I support this? What's the pattern that's here? Am I going to too novel of a pattern? Is this not going to be tenable? Is this going to have compatibility issues? Is it going to have a time-based compatibility issue? Is it going to be backwards compatible, forwards compatible?" So these are the things that get to be like quite unique and interesting. Come back to the graph, yeah.
Yeah, I wanted to point out, like with audio processing, it has to be fast. Otherwise, you're going to have a lot of clicking when either like your sample rate is too high or you don't have enough of a buffer. You need your audio processing to be quick. So, you hit the keyboard and you hear sound or your MIDI controller, whatever, and you want to hear sound pretty much right away. And normal audio or normal web workers can be an issue because you're passing all sorts of data to it. Like I said, that can be really slow. Audio, it's just numbers. It's just a sequence of numbers.
Yeah.
And so that is what lets worklets and audio worklets work so fast. And you can have so many of them and they can all work together and create this digital sound processing tree that makes beautiful sounds.
I love that. But the most unique thing I want to point out, I have developer tools open right here. And notice here in our web workers, I see an NPM package from Clerk.
Mm-hmm.
Presumably, this is about cookies and when authentication is going to time out. And I see 2 timers for Clerk, but I don't see a web worker for our web audio. Now, this could be for a multitude of reasons. This could be that when an application, so what happens is that when I go to dumbflstudio.com, a request is going to be made on a client. That client is then going to ping a server. That server then has to send information back. It's not going to send the entire payload over the wire because that's non-performance. And everyone fucking forgot about web performance, and it shows a lot. And so a lot of times you will not see everything until it is invoked at runtime. And this is one of the biggest things that makes debugging, especially on the client side, very challenging because you don't see what's actually happening yet. But don't you think it's interesting that there's no web worker showing up?
I do, and I have a couple of ideas on why. My naive assumption is that audio worklets, since they're not necessarily web workers, they might not show up here.
That's good point.
And there could be a lot of reasons for that. One being audio processing isn't super common. So adding a whole dev tool for it might not be on the top of their list. Or maybe I'm completely wrong about how it's being implemented. But
that's right. So let's take a look. So like originally what would happen is that you would come to the docs, you would read these, and even though React is a functional programming UI runtime, we can't call it a framework. Even though people are telling you it's functional programming, you just write a function, under the hood, everything is object-oriented programming.
Isn't that so funny? It's like one of my favorite things about JavaScript. It's so annoying that literally everything
is an object,
except
everything.
Your primitives, but even some of those are objects.
And most of your primitives are going most of your primitives, when they're good primitives that you can use, they are an object. And why is that the case? And that's because you're mapping the object, but it's also performant because of inheritance, because we have dunder properties. When we use dunder properties in object-oriented programming, that's how object-oriented programming is so efficient with memory storage, because I can inherit something and then I can have a pointer back to the property rather than re-replicating it.
Exactly.
And so when you get confused with anything, you have to remember everything is really object-oriented programming. There's a class, and a class is going to point to something else. And through understanding the object hierarchy, we can understand like how far our code is going before it actually gets executed. So that's why I always pull up the documentation. So these are Keegan's 3 keys to success, is that if you want to make a web workload like dumbflstudio, notice all the things it can do. Like if you wanted to now add things in, I can simply add this in. Do you want to do a quick demo? Because you didn't get a chance to demo the platform yet.
I didn't. I mean,
give yourself a chance to demo. I mean, demoing is the most important thing you can do.
I do want to point out some visual bugs, and we will fix some of those.
Nah, but demo first. Don't talk about the bugs.
Of course not. So let's close all of these pieces. If you know anything about music, it's basically a bunch of sounds that play over time.
Yep.
How do you play those sounds? Well, we have some that is called a channel rack. So you can just think of these as all your instruments. We can open these up. These are all opened up in iframes, and then that's just the GUI, and then we have the audio worklet in the back end. But each of these is a synthesizer. So I hope this sounds good. I don't know if you guys can hear that. But you can play your keyboard, and let's make a new pattern. We have our piano roll here, so we can make a nice little, chord there. I'm not used to Mac.
I know.
We can stretch this out. We can.
Wait, are you a Linux guy?
I'm a Windows guy.
Whoa, what?
I'm a gamer. I used to work on C#. So
wait, hold on. We have to end the stream because I'm choosing to end the friendship.
I'm so sorry, guys. No, my personal laptop is a Mac. But
yeah, but no, that's
I got a game on Windows.
Yeah. And I mean, they have Xbox. I get it.
We've got Xbox, So we have a bunch of really cool features, like our nice piano roll. You can play. Let's go to our pattern mode. We have our plugin browser. So we have all of our instruments. We have our effects. So if you wanted to add some sort of reverb, you can add it to the master bus here. We got 2 sets of reverb. Close these other modules. And then if we hit play, you'll hear reverb. You can hear it right here. You can also open the audio graph that I was mentioning before.
Oh, and it activates in real time.
It activates in real time. And we can do some fun here. We can change the channel that we're routing to. You can see it'll update in here. So now our Weblr synthesizer is being routed through our first insert, which then goes to the master.
That's really good. And so what's happening here is that we have one thing happening on the screen, and when the state changes, what we're seeing is that there's a downstream impact. Mm-hmm. In development, this is known as push-based reactivity. And then there's another reactivity called pull-based reactivity, which is like, if anything changes, I will automatically update myself. How did you think about reactivity for this? Because, I'm curious.
So I'm a big proponent of, push-based activity.
State machines?
So what's driving this is MobX. I don't know if you've used
MobX.
MobX.
Yeah, I know MobX.
The idea of observers and observability is just really nice. Not having to think about requesting my state or pushing my state, it should just all sync up,
Yep.
And I want to have reactions to things. So when I hit play, the audio graph, my audio engine shouldn't have to, make sure that the audio graph knows to animate this whole thing. My audio graph is just listening to a change in the state of whether or not we're playing or not. So it's super nice. MobX just makes things cleaner. It's easier to read. I don't have these super massive.
We're going to pull up the documentation and we're going to go to the source code briefly.
Yeah.
Let's do that right now. So the most important thing is every time that you hear about a framework, you want to go to the documentation.
And source of truth.
Yes, because the documentation it's canonical. When you are working with your AI agents, when you're working with anything, there is information and then there's canonical information. By making one simple request to ask for canonical information, you will save yourself so much inference and so much debugging because you're trying to go based on the state on like the actual truth.
The truth, yeah.
Yes.
I mean, how many times have you made a project and you didn't give a clear description? You didn't plan.
Yep.
You gave a vague ask, and it's using an outdated version of Tailwind or whatever. And
oh my God.
Now things aren't working together, and you're importing these components, and everything's broken. It's because you're using the wrong version.
Exactly.
All you have to do is ask for the latest or reference a specific version.
Now, this is really important with reactivity. Now, one of the most important things for everyone to know is computers cannot tell time. There is no time mechanism in JavaScript, nor is there a time mechanism natively on your computer. This is why date times are one of the biggest challenges in programming. Now, this challenging is not only associated with time.
You're giving me flashbacks.
Yeah, I know, right?
All the conversations.
Every developer, a real developer who developed before the year 2021, when you talk about date times and being responsible for date times, Keegan just had a flashback because that's when you, as a developer, that's when you can be fired. Because if you make a mistake here, this is, as a human, you're a three-dimensional creature. Time is a four-dimensional factor. You can get very lost in the sauce and you can get fired for not solving this problem, ironically, in a timely fashion.
Well, it's because there's a lot of downstream effects from getting the time wrong.
Yeah.
And again, if you don't plan right, there's going to be a lot of negative downstream effects.
Without a doubt. Now, not only do we have time, but computers need a concept of a clock. Now, computers are not going to use a standard time-based clock. They're going to use a vector clock. A vector clock is how reactivity is going to work. It's how pull-based reactivity is going to work, where what we're going to do is we're going to say a change was made. And that change that was made is going to be given an ID, and it's going to be given a UID, a unique ID for idempotency. Because if two things happen at the same time, how do we know what happened when? How do we differentiate? And that'll happen through a unique ID. And then a computer will use these unique IDs and timing things kind of based on that, and then differentiating them in that. And computers are going to use a loose vector clock type of system for this reactivity. So that's like a extremely important concept to understand as we go through this stuff. So we have your keys to success, planning, components, and this is a phenomenal web application. But
thank you.
When you went to render, you met my friend Jason Torres from JetBrains, and Jason is a film director. I spent my year being an AI engineer at a film studio so far. Now, I recently just joined an AI lab, Prism ML. I'm now in developer relations as well. But Jason is someone who, when I was trying to break into DevRel, we became friends on Twitter, and you met Jason at the bar. And do you want to tell me a couple of the insights you picked up from him about how to think about your job search?
Yeah, I mean, like, a lot of what he said I knew inherently, but I wasn't keeping it at the forefront.
Well, where did you meet? You met him at Render.
So I met him at Render.
But how did you bump into him?
So we were all getting drinks at this nice bar really close to the hotel. And, we just started chatting up about, jobs.
Wait, you were staying at a hostel, or where were you staying?
I was staying at the Ritz-Carlton, courtesy of Zach Chappell and Zephyr and
Yeah, okay, courtesy of Zephyr, okay?
Zephyr,
Keegan's
yes.
not a baller.
I'm not a baller. No.
But so you met Jason at a bar near the Ritz-Carlton. So
Yep.
the story's starting to form.
Yeah, and so like we just started talking about searching for a job, and I think the best way to gauge like how good a candidate is by talking to them and seeing how they are as a real human, and what better place to do that at a bar. And so I think it's really easy to kind of script what you want to say in your head at an interview, and when you go and say it, you sound like a robot, because you kind of are being a robot. You're not speaking from the heart and like just being a chill dude. Really, at the end of the day, you just want to be a chill dude.
Aha. Be a chill dude.
Or dudette.
Sage wisdom from the big homie. Sage wisdom.
So yeah, like, just be genuine. Like you can talk about how you want to make performance software and build cool things, and could say it in a way that is real. Give examples of what you build, like why you care about it.
So now, why don't we try to do that exercise that Jason helped you with? And let's imagine that you're interviewing for a job at Vercel, and you're going to explain dumbflstudio. So how would you explain it, like, given that you want to tell Vercel about this?
Well, dumbflstudio being a tool, especially a tool for creativity, you have to have the least amount of friction as possible. It needs to feel like an extension of yourself, because every time it's like a game. Every time you think about a glitch in a game, or like that you're playing a game, it takes you out of the experience. And so, I really put a lot of time and effort to make sure everything feels good. I want moving around, and this is a
that's like a fun Mac quirk.
But like opening up the piano roll and like copying things around, it should feel good. And so I put product a lot, and product is at the forefront of my mind when I'm creating something. And part of that is good UI, good UX. Good UX needs to sound good. So yeah, while building this, like at the end of the day, who really cares about the tech stack that you use or the architecture? As long as it feels good, it works, you can build on top of it. I mean, I didn't start out with this. I started out with,
A single screen,
and then I added the channel rack, and then I added the playlist, the piano roll, the mixer, the audio graph. But these are all separate components that tell a bigger story of what the application is. And so at the core, this is an audio engine. All of these pieces are a visualization and a way to interact with the audio engine. And making it feel good is the most important part of that. Being a tool, right? And so being a good tool, not to be a bad tool.
Yeah, and then also like I see a lot of times that people you're just taking the baseline thing that's coming out of AI, but everyone sees right through that shit, and you got to realize you're not fooling anybody. So let's talk a little bit more about how did you choose to architect this workload? So I'm going to make some assumptions. So what I'm going to do right now, this is called a black box analysis. My goal is I cannot see the actual code. However, I'm going to try to reason and understand how this was made, even though I can't see it. So the first thing I'm going to do is I'm going to inspect this, and I'm just going to inspect it from the outside. And a lot of times you can see a couple of tags. So the first thing I know is like, okay, you're using Cloudflare pages because I see a Cloudflare script at the bottom.
Let's go.
Okay, so I got that.
Yep.
All right, next up, let's take a look. I see React. So you're using React as a library.
I'm using React.
You are not using Next.js.
Not in this, no.
Okay, you see, but I would have picked that up from the top level, and I would have just known how to look at that.
Yeah, I mean, if I was using Next, you would have seen like it's
you would have seen
like,
you would have seen its footprints.
Yep.
And you would be able to see its footprints everywhere. Now let's take a look at some other things. So I see you have a subscription set up, and so this is probably going to be done for Clerk.
Yep.
And so, okay, so you're using Clerk, and that's going to be how you have identity and access management is through Clerk. So I got that one. Let's see, what else? Posthog.
Yeah.
Yep, I see a bunch of shit for that.
I was gonna say, can you find Posthog?
Yep. So now, what are other things I can do? So using the network tab is going to tell me, the data didn't just magically get here, it got over the wire. And so by looking at this, I can see everything coming over the wire. Then after it comes over the wire, I can also take a look at what are the elements rendered on the screen. I can take a look and I can see the sources of the workload as well. And I can see like, okay, if there's a compiler inside of here, I can see, oh, okay, well, this is going to be very specific for audio tooling. And then I bet you that my next thing is going to be trying to understand and examine the package JSON file, which will tell me a lot about the web workload. Now, the package JSON file is not going to be something that gets emitted over the wire. So that's something to definitely keep in mind as well. Let's see, is there anything else I can kind of glean from this? Storage, this is from here. Posthog, yeah, so I see Posthog again here.
There is something fun, yeah, about storage.
I see some cookies here. Oh, what's fun about storage?
So if you don't know, most people know about local storage or your cookies, which are good ways to hold kind of small information. This is a big thing. This can hold a lot of data. This can hold audio files, which can be megabytes.
Yeah.
Or even bigger. So you can use IndexedDB, which holds even more storage.
Yep.
And yeah, a really cool thing is like with audio, it's not just MIDI and synthesizers. A lot of it is, with your drums, you're going to bring, we don't have any examples here.
Yeah.
Just your raw wave files, your MP3 files, and you can reuse them. Open a new session and reuse the same drum samples.
That's nice.
It's stored in IndexedDB, and it just makes a reference to the
file. It's stored locally to IndexedDB. So, and then that saves you from needing a crazy CDN.
Yeah, until you want to share your file
across a team.
It's stored locally. So once you actually share a project, it's going to determine all the samples down here that you're using in the playlist in the actual song. And then it's going to determine like what audio files do you need to upload to object storage to package this save file up to. And then it's going to, I'll send you a link and then, we'll magically know what samples we got to drag down so that you can also play and mess around with it.
Oh, that's cool.
But the big thing I just wanted to mention was IndexedDB. It's just like another mechanism to save data locally.
Yeah, I love that. So what I was just doing briefly was I wanted to see, we do have one audio file. And so what you can do is you can set a breakpoint. So what I would love to do briefly is I want to set a breakpoint. I want to share the link, and then I want to see the data that will be sent over the wire because there's a request and a response.
So that's all local. I don't have that published yet.
Oh, okay. And so now take a look. These are, remember, Keegan's keys to success was first having a plan, modularizing this, using web workers, and then when you modularize things, the scaffolding is in place. You can use the app, and then when the user asks for it, like it just happened, I could be like, okay, let's program that feature in. And now that actually gets into the final point, which is, oh, that feature is missing. Is that the type of feature that you think that we could try to do with Codex?
It absolutely is. I mean, right now, I think that might take a little bit more planning. Making sure we have the. This is more DevOps stuff. Like we have to make sure we have the infrastructure in place.
Oh yeah, for supporting having a web link, because then how's the web link going to work? It's going to have to pull from where?
Yeah, exactly. Whether that's R2 or.
Exactly, and so then infrastructure must be set up. So you have an application runtime, but the application runtime is limited to what specialized infrastructure it's going to run on and the fact that that's running and available.
Exactly. And so there are a few things that I would love to fix, and let's see if we can.
Yeah, let's find a small bug.
Yeah. So there's a feature like, I wouldn't recommend clicking it, but if you click export, it's going to, there we go. It's going to download what you would think would be like a WAV file, but it's actually just like a bug report. It's just the actual project itself.
Okay, so you know what? This is a good opportunity for us because we're going to inspect what is happening at runtime when that occurs. What I'm going to do is, inside of here, I'm going to set a breakpoint. And so what I'm going to do is, whenever we hit the export button, that is a click. So what I would be able to do is, let me come over to the workload.
All right, so I do have a fix.
Oh, what is it?
It added a forward audio renderer. I had like some experiment already.
Oh, okay. So you already have a branch in place.
I have a branch with some experiments. We'll see if it does a good job.
Okay.
Let's pray to the demo gods and make sure that we get a good demo here.
All right. So first, I'm going to reproduce what we just downloaded.
Yeah, let's show it off.
And so the downloaded piece is going to be
neonsketch.gridline.
Neonsketch.gridline. So right now, when we hit export, you would expect an audio file, but instead we are getting this. And so what we're going to do is, remember, at the very beginning...
Show how big that file is.
Yeah, that's a massive file. Let's go look at this.
And like, there are optimizations I think that I could make. I'm sure there's some that you can think
Yep.
of, like some sort of serialization. A lot of things we can do, but this makes it really easy for Codex to understand.
Yep.
And so specifically, this is the debug file.
Yeah. And one of the hidden quirks about audio, you think that video would be bigger than audio, but that's not the case. Audio has more data than video, despite the fact that video has both audio and fucking video. Did you know that?
That doesn't surprise me, particularly because like we have so many optimizations for compressing video and so many different tricks, like interpolation.
Oh, yeah.
It's easy to naively think like every frame is a brand new image, right?
Yeah.
But there's really some sort of, for lack of a better word, magic happening. We just track which images or which pixels have changed. So there's a ton of compression that we can do.
So through a performance technique, this was a cheat.
With making video small, yes.
And so then we would surmise that with AI models, where a 27 billion parameter model is really 54 gigabytes, can't fit on your machine. If we were to have some engineering work, we would be able to get past these problems. And this is why everyone is excited to invest in AI.
Yeah.
It's because there's a lot of room for optimization. We're still early innings. So how's Codex doing right now?
Let's see.
Ooh, pushed.
It's pushed.
All right. And then could you ask it to report on CI/CD?
I could.
Do you have that connected with your Vercel account?
I do not. So the Vercel project, I have all this in a big mono repo.
Okay.
The Vercel project is what I use to create the actual synthesizers.
Okay.
Because synthesizer development, if you want to go back, synthesizer development is extraordinarily complex. So this is an extremely feature-rich project. Let me take control for just a second. I mean, like this alone, there's a lot going on here. Let's close all this. There is a lot going on here. We have 3 oscillators. We have our envelope, our chorus. We have an arpeggiator. We have a lot of filtering going on. We can, we have pulse width modulation going on with our one of our oscillators. this is a lot of work. Like, as you can probably assume, like, this also is a lot of work. We have two oscillators here. We have, different views. We can change the sample that we're using for the oscillators. We have a sub in this one synthesizer, noise in this one synthesizer, a filter. We can right click on any of these. We can add a modulation source. We have our modulation matrix here. There's so much to this. You have to understand audio to like the next level to really create a good sounding synthesizer. You can, and I have tried to ask Codex to just make a synthesizer, and that is what this is. You can see this isn't very complex. We have 8 parameters we can change. It sounds okay, but it doesn't sound great, and you're very limited on what you can do. So I'm working on an Eve app with Next.js, where you just use natural language to talk with an AI agent, uses AI SDK to kind of parse what you want and what the requirements are going to be. Like each one of these little components here, these cards, it's a rack. So it's going to determine if you want 2 oscillators, okay, we're going to need 2 racks for your 2 oscillators. If you want some sort of LFO and a filter or anything else, it's going to, figure out what that needs. Or if you want some sort of wavetable or a sampler, it'll think about what else is needed for that. And then it'll parse it into a nice JSON structure, and then feeds this to another agent that can kind of determine like what are all these parameters, how are they all talking to each other, what are they doing, and what sounds good, more importantly.
Yeah.
And so that's what I'm working on now, and it's going to publish to a registry. Here we go, latest version. You can see the release notes.
Oh, and we see a total change.
A complete change.
And now it did the rendering that rendered exceptionally fast. And then now, we got a wave file. Holy shit. Oh.
Let's just do our banger song.
Yeah, dude. Neon Sketch. Wow. So that successfully exported.
It did. And it also added one more thing I just saw. So right up here, this is an oscilloscope. Are you familiar with an oscilloscope?
Yeah.
So we can, let's open up this pattern here. Close all this noise. Let's open up one of these. Does this work? Oh no, the oscilloscope seems to be broken.
That's another bug report, y'all.
Another bug report. But I think it is working. It is. It's just too quiet.
Yeah. And so these things can happen, but take a look, everyone. What we just did was we inspected a code base. We didn't have a laptop in front of us. We were still able.
Let's see what we got. We got cut remainder.
And then, that.
Change the bit depth, the sample rate. A lot. That's pretty cool.
It's amazing. So remember, the keys to success, when you have a plan, you think about components, you modularize things, and then you use the correct web APIs. You can create a great application. And then when you have the real skills, you don't even need a laptop to push your changes when you really know what it is that you're doing. And so I guess to close things out today, your big keys to success are going to be to have a good plan, use components, use web APIs, but then connect with amazing people like Jason. At RenderATL, and just keep trying and trying every day to get 1% better. And you as the person, you're still going to beat the shit out of AI, I promise you, because a lot of what we're being fed right now is a total lie on capabilities. So keep betting on your skills. Keep trying to do the craft. Cheap people are always going to be cheap and stupid. So keep that in mind. Keegan, any parting words?
One more thing I think we forgot to add to this list, which is hang out with your friends.
Right? Hang out with your friends. Keep this in mind. 2 months ago, I met Keegan. And then immediately when we met, I made a third friend, Adrian, who you already knew. Later, 2 days later, we went to the same meetup because I invited them there. Adrian gave a demo that changed my career. Adrian from LM Studio, he made an iPhone app for using local AI. He told us that night, he said, we will have Sonnet 4.5 level intelligence running on your phone. I want you to know all the Y Combinator businesses are just using medium level intelligence in a loop to do stuff. So a lot of the software is just made by that with someone with a high tolerance for pain and no real experience.
And that's exactly where a plan comes into place. Because you can brute force something and get mediocre results if you have no idea what you're doing. But if you have a plan, it kind of supplements the lack of intelligence in these mediocre models.
But there's one thing that happens before a plan, and this was Keegan's last point. This is direction. And so sometimes you can get direction from a professional film director. I'm going to say, direction. There we go. So with Excalibur, sometimes with the text, it's a little hard.
It is.
But sometimes you need direction. For me, I needed direction from our friend Adrian to focus on local AI. For Keegan became friends with one of my other friends without even meeting me. Rude. But he got direction from a professional director, then used that for his plan. So this is step 0. And step 0 is direction, or really just hang with friends. And now with that being said, it's time
Cheers.
for another drink.
Yes.
So we'll see you guys in the next one. All right, I'm going to end the stream now, find where it is. Screen of death. We'll see ya.